Hello dear friends. Today we start the lecture number 2 of kinematics. In the last lecture, that is lecture number 1, we have developed two important variables of kinematics. And today we will develop the second basic variable of kinematics, that is speed and velocity. Actually, we will be discussing the average speed and average velocity in this lecture. So, we have the idea of displacement, that is a particle changes its position and we say that the particle is moving. Consider a particle moving like this. A person starts from point A and walks to point B and let this distance be 10 kilometers. The person walks from A to B, that is 10 kilometers, and takes 150 minutes. 150 minutes, that is 2.5 hours for that. Suppose another person is moving from A to B in a car. This is a car. This is walking. And he takes 10 minutes for reaching here. And if you consider only the displacement of the particle, we can see that the person who is walking and person who is moving in a car have the same displacement. Now, what is the difference between these two? In common sense language, we say that car has moved faster. That is, he has reached the destination quickly compared to the person who is walking. And how do we take this idea in more technically perfect form? And technically, we say that the rate of change of position, rate of change of position of both are different, even though the change in position for both travelers are same. The rate at which they are changing their position, or they are moving from one place to another, or the rate at which they are displacing is different. And we call this rate of change of position more correctly the rate of displacement. Rate of displacement as velocity. This is called velocity. Rate means it is divided by time. We are considering the time rate of the particle. So we have velocity, which is displacement divided by time. This velocity actually comes in two ways. That is, we can have the velocity. This is average and this is instantaneous. Average means we average the velocity during a particular duration of time. That is what we mean by average. Instantaneous means we are considering the velocity at a particular instant of time. The reading of the speedometer of your car. It is actually representing instantaneous velocity. But the total distance covered divided by total time taken, that will be representing the rate at which the displacement is, or the position is changing. So that is the idea of velocity. We can say that average velocity, this we usually represent by a curly bracket on both sides. Some people mark it like this. Your NCERT textbook uses this convention, an overbar, but overbar will make you bit confused when you deal with vector. Vector also is given by this type of symbol. Therefore, to avoid that confusion, I will be using this symbol for average values. For any average values, I will be using this symbol. And this is equal to total displacement divided by total time. When you use this, you have to be slightly careful. By total time, we do not mean the entire duration of motion. It will be, by total time, what we mean is the duration of motion given. For example, if you are asked to calculate the average speed for 10 minutes, you will not be taking the entire duration of motion, but only the 10 minutes. If you are asked to calculate for 20 minutes, you take the time duration as 20 minutes. And the average value will be different when the time duration changes. So, by total time, we are actually meaning the duration of, not motion, the duration of time given. And total displacement is the displacement, not the total displacement, but the displacement for the given duration. For the given duration. So this you should be careful. It is not the entire motion. If entire motion is asked, then you have to take the total displacement, that is the displacement for entire motion, and divide with the entire duration. But if it is asked for a small interval of time, then you have to use the displacement corresponding to that time. That is a very important point you have to remember when you calculate average velocity. The duration will be given. The duration changes, the velocity, average velocity also will be changing. And if average remain same for all intervals, then we have a uniform velocity motion. Sometimes it is called uniform motion. Uniform motion means you take the average for first 10 minutes, you get a value. Next 10 minutes, you get a value. Next 10 minutes or 5 minutes or 2 minutes, whatever be the time duration, you take the average value, all of them will be same. And the instantaneous value also will be same. That is called a uniform velocity motion. A particle traverses or covers equal displacement in equal intervals of time. That will be called a uniform motion. And the unit, clearly for this particle, unit will be meter per second. Dimension will be L T minus 1. Sometimes we take kilometer per hour also. We can see that x kilometer per hour is equal to x multiplied by 1000 meter divided by 60 multiplied by 60 second, that is equal to x multiplied by 5 divided by 18 meter per second. Usually in your questions, kilometer per hour is given as multiples of 18, 36, 54, 72, 90, 108, like that. Then you don't need to multiply this. Otherwise, you have to multiply 18 kilometer per hour corresponds to 5 meter per second. 36 corresponds to 10, corresponds to 15. 72 corresponds to 20. 90 corresponds to 25, like that. So you can easily convert something given in kilometer per hour to that given in meter per second. That can be easily done. And we know that displacement divided by time is a scalar quantity, displacement is a vector quantity, therefore velocity, average velocity is a vector. When you consider one-dimensional motion, we don't need the entire mathematical machinery of vector analysis. Instead of that, you can use plus sign and minus sign. Plus sign represents vectors directed towards right or up or towards you, and negative sign represents left, down or away from you. That we have seen in connection with our displacement discussion. This can be positive, negative or zero, just like displacement. Displacement can be positive, negative or zero. Similarly, this also can become positive, negative or zero. Now we pass on to the speed of the particle. We can consider the speed of the particle, and speed of the particle is the average speed. Average speed, which we represent like this, is equal to total distance, that is the total path length. Total path length, total means the path length corresponding to a given duration, divided by total time. Total time means the given duration. If you replace displacement by path length or distance, we will get the average speed. And this will be, distance is a scalar, therefore this will be a scalar. The unit and dimension of both speed and velocity are same. Now we compare the speed, average speed and average velocity. Here we have average velocity. Here we have average speed. This is a vector. This is a scalar. This is kilometer per second LT minus 1. This also meter per second LT minus 1. This can be positive, negative or 0. This is always positive. In general, speed is greater than or equal to magnitude of velocity, average velocity. Average speed will be greater than or equal to magnitude of velocity. Sorry, this is magnitude of average velocity. They are equal only for unidirectional motion. This we have seen in connection with our displacement distance lecture, that is in lecture 1. For unidirectional motion, these two are equal. Otherwise, they are not equal. And now, in general, they are unequal, but the magnitude of velocity can never be greater than speed. It will always be less than speed or equal to speed. Equal to speed when the particle moves along a straight line without changing direction. If the direction is changing or particle reverses, then these two values, that is the magnitude of velocity and speed, will be different. They are equal only for a straight line motion, that is one dimensional motion along a line unidirectionally without changing the direction of motion. Now we take an example. Consider a particle starting from P reaches a point Q and then reaches here a point R. Let this be 0. Let this be 36 meter. Let this be 24 meter. Let this time be 0. This time be 18 seconds. This time be 24 seconds. So it takes 18 minutes to travel from P to Q and 6 minutes to travel from Q to R. It travels 36 meters from P to Q and 12 meters from Q to R. First we will calculate average velocity and speed. Whenever you are asked to calculate the average value, the duration should be given. If duration is not given in the question, you can take the entire duration. Here we are specifying the duration for 18 seconds. We know that we will calculate velocity first. Displacement is equal to 36 meter. Time is equal to 18 seconds. Therefore, this is 2 meters per second. Average speed, distance equal to 36 meter. Time equal to 18 seconds. Therefore, this also 2 meters per second. So you see that the magnitude of velocity, it is a vector actually from P to Q. This vector has a magnitude 2 meter per second. This value is 2 meter per second. So in this case, the magnitude of velocity and speed are same, because from P to Q, you are not changing the direction. It is a unidirectional motion. Particle moves unidirectionally. But if you change this time to 24 seconds, you can see that the displacement will be a vector from P to R, and that will be 224 meter. Therefore, this 36 meter becomes 24 meter, and 18 second will become 24 second. 2 meter per second will become 1 meter per second. From P to Q becomes P to R. Speed is the distance traveled by time. Distance here is 36 plus 12, that is 48. This becomes 48 meter. This is 24 second. Therefore, it is 2 meter per second itself. In this case, the magnitude of velocity is smaller than the speed. Speed is greater than the magnitude of velocity. That is because this changes direction. So whenever direction changes, we can say that whenever direction changes, there will be these two quantities will differ. Now, understanding this idea, we will use this, or we will develop a small piece of information or a small theory which is useful in solving certain special type of questions. That special type of questions usually appear for JEE Main and also NEET. The special type. Special type means 1. The first case, time interval same. That is the characteristics of that type. Given time interval is same. You are given that a particle travels with a velocity v1 for first half time and with a velocity v2 for the second half time. We will take that example. A particle travels, this time is 0, this time is t, this time is 2t. So we have two equal time intervals. Time interval same. This velocity is v1, this velocity is v2. We call this distance as d1, this distance as d2. You can see that d1 is equal to v1 multiplied by t. d2 is equal to v2. Displacement, total displacement is equal to d1 plus d2 is equal to v1 plus v2 multiplied by t. We have taken t as common factor. Total time is equal to 2t. Therefore, the average velocity v will be equal to v1 plus v2 multiplied by t divided by 2t. We kill these t's and we will get v is equal to v1 plus v2 divided by 2. That is a very simple idea, because if you are given that the particle travels with 10 meter per second for first half and 20 meter per second for the second half, you don't need to do any calculation. You can simply say that the average value is 15 meter per second. So that saves lot of time in answering the question. This can be considered in general if we have 3 time intervals, same time interval, that is, this is t, this is 2t, and this is 3t. This velocity is v3, this velocity is v2. Then this will become d1 v1t, d2 v2t, d3 v3t. Then this will become v1 plus v2 plus v3 multiplied by t, and this will become 3t, and you will get this formula as v1 plus v2 plus v3 divided by 3. In general, if there are n intervals, n equal intervals, and n velocities, n equal intervals and n velocities, then the average velocity, if it is unidirectional, that will be, its magnitude will be same as that of the average speed. Therefore, we write only the average velocity. That will be equal to v1 plus v2 plus etc. plus vn divided by n. You all know that this is called an arithmetic mean. Arithmetic mean. Adding them together and dividing by the number. This is the ordinary average you learn in high school. All quantities added together, divide by the number. This is called an arithmetic mean. So, when the time interval is same, in the question it is given that time interval same, then the average velocity will be same as the arithmetic mean. Now we take the next case. That is, instead of the time interval same, we are given the space interval same. Space interval same. That is, same distance. For example, you are given that the particle moves with velocity v1 for the first half of the distance and v2 for the second half of the distance. Here, time is not remaining, time is not same, but distance is same. What will we do when distance is same? We will consider that case. This is 0, this is d, this is 2d, this velocity is v1, this velocity is v2. This time we will call as t1 and this time we call as t2. They are not same. Distance are same. This is d, this is d. Then we can say that t1 is equal to d divided by v1. Because this distance is d, velocity is v1, distance divided by time is velocity, so time is distance divided by velocity. Similarly, t2 is equal to d divided by v2. So, total time is equal to d divided by v1 plus d divided by v2 is equal to d multiplied by 1 by v1 plus 1 by v2. Distance is equal to 2d. So the average speed is distance divided by time, 2d divided by this, d will cancel and this will become 2 divided by 1 over v1 plus 1 over v2. As in the previous case, we can generalize this. Let there be 3 equal time intervals. Then this will be 3 divided by 1 by v1 plus 1 by v2 plus 1 by v3. If there are n space interval, then we have average velocity. It is given that the particle travels with velocity 10 meter per second for first 1 by 5th of the distance, 15 kilometer per second for the next 1 by 5th of the distance, like that. And there n is equal to 5. N general, the formula will be n divided by 1 by v1 plus 1 by v2 plus etc. plus 1 by vn. You can easily see that 1 by v1 plus 1 by v2 plus etc. 1 by vn divided by n. This n comes here. That is the arithmetic mean of the reciprocals of velocity. But n goes up, that means we again take the reciprocal. So this is actually the reciprocal of the arithmetic mean of the reciprocals. That particular quantity is technically called a harmonic mean. We have use of harmonic mean also in several situations. So remember this, if the time interval remains same, you take the arithmetic mean of the velocities. If space interval remains same, you take the harmonic mean of the velocities. Then we have to use these ideas in certain numerals. So we will pass on to working out certain important numerals. The general numerals in kinematics we will discuss after completing the entire topics in discussion. This is kinematics is a basic topic. I am starting it from the beginning. Therefore, it will take some few lectures for completing this chapter. I will be giving all the mathematical tools required for that: integral calculus, differential calculus, vector analysis, etc. All these will be given enough to understand the concepts of physics. So we will work out the numerals, simple numerals using this, and the numerals which are appearing at the JEE main, NEET level, etc. will be discussed completely, almost thoroughly, when we complete all the lessons in this. Few simple questions from this part. Before looking at the solution in the video, you pause the video for some time, try the solution yourself, and then come back to the video and compare your solution with the solution which is given here. That is the best way to develop your problem solving skill. So question number 1. A ship travels towards east with a speed of 12 kilometer per hour for 1 hour. It turns south and travel at 5 kilometer per hour for 1 hour. Find the A, average speed, B, average velocity. I am doing everything completely, therefore it will take some time. But when you are doing it in the actual examination, it will take only very little time. So, we draw the figure, start from here, travels towards north, this is the north direction, for 1 hour at 12 km per hour. So, this distance is 12 km. Then he moves towards south, this is the south direction, for 1 hour at 5 km per hour. So, this distance is 5 km. And therefore, total distance equal to 17 kilometer. Total time equal to 2 hours, and therefore average speed, distance divided by time, 17 divided by 2, that is 8.5 kilometer per hour. The displacement is this. This is the displacement. This angle is theta, and this distance is square root of 12 square plus 5 square is equal to square root of 169 equal to 30. 12, 15, 12, 5, 13 is a Pythagorean triplet. So this distance is 13 kilometer, and therefore the average velocity is displacement 13 divided by time 2, that is 6.5 kilometer per hour. See that the magnitude of velocity is 6.5, speed is 8.5. This is smaller than this. They are not equal because it is not unidirectional. It changes the direction during motion. Second question. An athlete runs along a circle with a speed of 24 kilometer per hour and completes half revolution in 5 minutes. Calculate the average velocity for 0 to 5 minutes. He starts from here and he completes a circle, reaches here. This is half revolution. This distance is r. This distance, curved distance from A to B, this is 24 kilometer per hour and time is 5 minutes. 5 minutes means 1/12 hour. Therefore, 24 multiplied by 5 divided by 60 or that is 24 divided by 12 equal to 2 kilometer. Therefore, pi r is equal to 2 kilometer. This is half circumference is pi r. Therefore, r is equal to 2 divided by pi kilometer. Now we have to find the displacement from A to B. This is the displacement vector and this is r. This is r. Therefore, this total distance will be 2r. So, the average velocity will be 2r divided by time taken, that is 5 minutes. That is, this is 2r. R is 2 by pi. Therefore, 4 by pi multiplied by 5 minutes is 1 by 12. Therefore, this is equal to 48 divided by pi kilometer per hour. We don't need to calculate the average speed because average speed is given. 24 kilometer per hour, it is moving with a uniform speed. It is given, therefore we need to calculate only this, and 48 divided by pi is smaller than 24 kilometer per hour because it changes the direction. Third question. A car traveled first 1/3 of distance with a speed of 10 kilometer per hour. Next 1/3 with 20 kilometer per hour, and last 1/3 with 60 kilometer per hour. And we know that this can be easily done using our shortcut trick. That is, when you have equal distances, the average velocity here, it will be same as the average speed because it is not changing direction, will be the harmonic mean of velocities. So this is equal distances. Equal distances. Equal distances means we take the harmonic mean, n divided by 1 over v1 plus 1 over v2 plus etc. 1 over vn. Here n is equal to 3. Therefore, the average velocity will be equal to 3 divided by 1 over 10 plus 1 over 20 plus 1 over 60. The LCM is 60. 3 divided by 60 upon, this is 6 plus 3 plus 1, that is equal to 3 divided by 10 divided by 60. 0 will cancel, 6 will go to the top, and this will be 18 kilometer per hour. So you don't need to calculate the total distance, take the total time, divide the total distance by total time. All those things need not be done because here we have equal distances. When equal distances are there, the value will be, that can be easily done by using our trick. This is question number 4. A train travels from A to B at a speed of 10 meter per second, at a speed of 10 meter per second, and returns to B at a speed of 20 meter per second. Find the average speed. For the entire journey. We don't need to calculate average velocity because that is 0. It comes back to the original condition, original position. So displacement will be 0. So we can say that the average velocity will be 0. And this is also an equal distance situation. Equal distance. Here n is equal to 2. Therefore, average speed is 2 divided by 1 over 10 plus 1 over 20, that is 2 divided by 3 over 20, that is equal to 40 divided by 3, which is equal to 13.3 meter per second. Therefore, this is 13.3 meter per second. So here also you don't need to calculate the distance, time, etc. You can simply use this because the distance from A to B and distance from B to A are same. If you can bring the question to that form, then it will be easier. Very easy because you can take the harmonic mean of the situation. Question number 5. During the first 18 minutes of travel of total duration (60 minutes), the average speed is 11 meter per second, and for the remaining 42 seconds, speed is V. Find V if the average speed for 1 hour is 21 meter per second. So we are given that the total travel distance 18 minutes at 11 km per hour, then 42 second with V meter per second. So the distance equal to, for first 18 minutes, that is 18 multiplied by 60 second multiplied by 11 divided by distance, this plus V multiplied by 60 multiplied by 42, and the time is 60 multiplied by 60 second. So average speed will be equal to 18 multiplied by 60 multiplied by 11 plus V multiplied by 60 multiplied by 42 divided by 60 multiplied by 60. I have changed all to seconds. So 160 will cancel and you will get this equal to, this quantity will be equal to, the distance will be equal to 18 multiplied by 11 plus 42 multiplied by V divided by 60 is given to be 21. Now you can 18, this you can multiply, divide with the 6, this becomes 3, this becomes 10, this becomes 7, and this will become 33 plus 7V is equal to 210. You multiply this 21 with 10, 11 multiplied by 3 is 33, 7 multiplied by V is 7V, and 7V is equal to 210 minus 33 equal to 177. So V will be equal to 177 divided by 7, which is equal to 25.3 meter per second. That will be the speed for this 42 second. But this is bit lengthy and I will give you a shortcut for doing this. You can see that here we have two time intervals, 18 and 42. You calculate the HCF, highest common factor, of 18 and 42, and this will be equal to 6. That means the entire journey can be divided into 6 second interval, 6 minute interval, total 60 minutes. Therefore, there will be 10 intervals. Out of that, first 3 intervals travels with 11 meter per second. The second 7 intervals travel with V. And now this is a situation of equal time. Equal time in the sense that this is, you divide this into like this, into 10 equal parts. This will be 6, 6, 6 like that. And for first 3 of them, this will be 18, and next 7 of them, that will be, you have to calculate V. So we can use the equal distance principle. There total there is 10 intervals. Therefore, V will be equal to, that is 3 multiplied by 11. This is the V plus V plus V 3 times, plus 7 multiplied by V 7 times. This divided by 10. This is for equal time interval, so you have to take the arithmetic mean. This is arithmetic mean. So you can simply write this relation and this is equal to 21. Then calculated and it will be converted to an equal time situation where the average velocity can be calculated by simply taking the arithmetic mean. Is a question from your NCERT textbook. A man walks on a straight road to a market 2.5 kilometer away with a speed 5 kilometer per hour and immediately return. In your textbook it is given that finding the market closed, he immediately returns. Immediately return at a speed of 7.5 kilometer per hour. Find average velocity and average speed for A. 30 minutes, B. 50 minutes, C. 40 minutes. Before doing that question, we just analyze his motion. What is his motion? He starts from here at t equal to 0. He travels with a speed of 5 km per hour. This distance is 2.5 km. And he reaches here. If he moves with 5 km per hour, 2.5 divided by 2.5 km is the distance divided by velocity. Velocity is 5, 2.5 divided by 5, that is half. Therefore, the time will be, time t for the first part will be 2.5 divided by 5 equal to 1 by 2 r, which is 30 minutes. Then he returns with a speed of 7.5 km per hour. So that time, it will be t prime, is equal to 7.5, distance is 2.5, divided by 7.5, that is equal to 1 by 3 hour. 1 by 3 hour is 20 minutes. Therefore, he reaches back at a time of 20 minutes. And he is 7.5, he takes 20 minutes to cover the entire. Therefore, he takes 10 minutes to reach the middle point, which is 1.25 km. This is the motion. Now we can use that to calculate one by one. A. You have to calculate the average velocity. The displacement is 2.5. Time is 1 by 2. So this is 5 km per hour. B, it is, distance is 2.5. Time is 1 by 2. So this also is 5 km per hour. We can see both are same because it is not changing the direction. So the first part, the speed and magnitude of velocity are same. Now the next part. Next part is for 50 minutes. We will calculate the velocity. In 50 minutes, he will reach the original position, and therefore average velocity is equal to 0. Average speed, the total distance is 2.5 plus 2.5. Time taken will be 50 divided by 16. 50 minutes, total 50 minutes. 50 divided by 60 hour. So this is 5 into, this is 2.5 plus 2.5. This is 5. multiplied by the 0 will cancel, 6 divided by 5. 6 kilometer per hour. That is for 50 minutes. Now take the case of 40 minutes. For 40 minutes, you have the displacement like this. This is the displacement, that is 1.25 kilometer. So distance is 1.25 kilometer. Time taken is 40 minutes. That is 40 divided by 6. That is 1.25 divided by 2 multiplied by 3. That is 3.75 divided by 2. In your NCERT textbook, they are multiplying this with 4. Then this will become, you multiply this with 4, this is 15. You multiply this with 4, that will be 8. So they are writing the answer as 15 divided by 8 kilometer per hour. But we can work out that this will be 1.875 kilometer per hour. And in that situation, that is for 40 meter, the distance divided by 2. This will be the answer. This will be 3.75 11.25 divided by 2. This multiplied by 4 will give you 45. Therefore, NCERT textbook write the answer as 45 divided by 8. You can work out that 5.25 kilometer per hour. This is question number 7. Displacement of a body is given as A equal to, displacement is equal to A sin omega t plus dt, where omega is a constant. And you are asked to calculate what is the maximum value of displacement. Sin omega t plus theta is equal to 1. Sin omega t plus theta is equal to 1 implies omega t plus theta is equal to pi by 2. So, omega t plus at what value determine what is the maximum displacement, what is the time for maximum displacement. You correct the question. What is maximum displacement is always A. What is the time for maximum displacement? Omega t plus theta is pi by 2. Omega t is equal to pi by 2 minus theta. Therefore, t is equal to pi divided by 2 omega minus theta divided by omega. At this particular time, that displacement. Next question is a question from the famous problem book, Problems in General Physics by Irodov, and people who are preparing for advanced level, JEE advanced, usually depend on that particular book. That question is, a particle traveled the first quarter of the distance. first quarter of the distance with a speed v0 for the remaining part this is first half. For the remaining half, he travelled with v1 for first half time and v2 for second half time. Find the average speed for whole journey. If you properly use our method for equal distance and equal time, this problem can be easily solved. Otherwise, it will be a long process. So I will be using that method. First I take for the second half. If you take second half, it is equal time. Therefore, its average speed will be equal to v1 plus v2 divided by 2. Because it is equal time, you have to take the arithmetic mean. For the whole journey, now we have equal distance, because for the first half it is v0 and for the second half it is v1 plus v2 by 2. Being equal distance, therefore the whole journey average speed will be 2 divided by 1 over v0 plus 2 over v1 plus v2. This is equal to 2 multiplied by, this is v0 multiplied by v1 plus v2, that will go in the numerator. Here this is v1 plus v2, this is v1 plus v2, this is 2v0. So the answer is 2v0 multiplied by 2v0 multiplied by v1 plus v2 divided by v1 plus v2 plus 2v0. Even though it is a it will appear to be very complicated, the problems in Narodov is like that. If you know the correct technique, that can be easily solved. So because those questions actually gives you a test of your conceptual clarity. If your concept is clear, you can very easily solve those questions. Here we have to use our equal time concept as well as equal distance concept. If that is simultaneously used, you can get and easily the answer. A particle travels 1/4 of the total distance, 1/4 of the total distance one-fourth of the total distance with a speed v1 and the remaining part with speed v2 and remaining part with speed v2. Find the average speed for whole journey. This also you can use our technique. This is actually an equal distance problem, even though it is given that for first 1/4 the speed is v1, second 3/4 the speed is v2. We can consider the next 3/4 as 3/1/4 with same speed v2. So it will be 4 equal spaced intervals. So 4 equal space intervals. When it is equal space interval, you have to take the harmonic mean. So the speed, average speed will be equal to harmonic mean. Now we have 4 space intervals, therefore 4 divided by 1 over v1. First one is v1. So 1 over v1 for the first quarter plus. For the remaining 3 quarters, the speed is v2. So we have 1 over v2 plus 1 over v2 plus 1 over v2. That will be 1 over v2 plus 1 over v2 plus 1 over v2. That is 3 over v2. So 4 divided by 1 over v1 plus 3 over v2. So this v1, v2 will go to the top, and this can be written as 4 divided by v2 plus 3 v1, v2 plus 3 v1 divided by v1, v2. That is equal to 4 v1, v2 divided by, this is v2, 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 this is 3 v2, this is v2, this is 3 v1. So v2 plus 3 v1. That is 4 v1, v2 divided by 3 v1 plus v2. This will be the answer. A man walks on an equilateral triangle. An equilateral triangle along the path ABC with the constant speed. The figure is given. This is the equilateral triangle. All sides are same, and you call this point as A, this point as B, and this point as C, and then they have find the ratio of average speed to average velocity for moving from A to C. he is moving with the same speed, uniform speed. Therefore, this side I take as A, this is equilateral, therefore this is also A, this is equal to. Let the time taken for this journey, let it be T. The time taken for this journey also will be equal to T. Therefore, total time is equal to 2T. And total distance is equal to 2A. Displacement is equal to A. So we can see that the average speed is equal to distance 2A divided by time 2T is equal to A divided by T. Average velocity, displacement is A divided by time is 2T. So that will be equal to A divided by 2T. So now the ratio is equal to A divided by T divided by A divided by 2T. This A will cancel, this T will cancel, 2 will go to the top, and the answer is 2. The last question, that is something which is not very much related to the speed, but I introduced that to make you understand one idea. A 150-meter long train the length of the train is 150 meter. A 150-meter long train moving with a speed of 45 km per hour. Moving with speed of 45 km per hour. The time taken to cross a bridge of length 850 meter. So this is your bridge. This is 850 meter. This is your train. And so, in order to cross the bridge, that means this point has to cross the bridge. So the total distance to be travelled will be equal to this 850 meter plus this 150 meter. Therefore, the distance is equal to 850 plus 150 equal to 1000 meter. That will be 1000 meter, that is 1 kilometer. 1 kilometer it has to cover. So the distance is, the speed is 45 km per hour. Therefore, the time is equal to distance divided by velocity, that is 1 kilometer divided by 45 km per hour. That is equal to 1 divided by 45 hour is equal to 1 divided by 45 multiplied by 60 minute, that is equal to 4 by 3 minute. it will take 4 by 3 minutes to cover 1 kilometer.